Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello, dear students. Once again, welcome to the TV learning series program. Still, the same person, Patrick. I will be with the Senior 3 chemistry class. And we are starting a new unit, which is unit number 7, and which it's about the concentration of solutions. Our lesson, we just look at the units of concentration, and then we look at how we can be able to prepare some solutions. So please, I invite you once again to be with me in this 30-minute session as we go through together. But by the end of this lesson, I beg your pardon, I want you to be able to state the units that will be used in the calculations of solutions, and then you have to explain how different solutions of different substances are prepared by this solution method, or we can call it the weighing method. So that is what we are expected to look at and what we are expected to have or to remain with by the end of this session. So when we talk about the solutions, I know it's not something that is new. We make solutions at home when we are either making some tea or coffee or whatever kind of drink you are going to take at home. Sometimes after the boiling some water or the milk, you put some sugar. When you put the sugar, you're making a solution. You're making the solution. That means the solute and the solvent are coming together. Those are the important words that you should not forget when we talk about concentration of solutions. So you either put one teaspoon or you put 2. Most of you even like too much sugar, which is not necessary, because most of the foods that we take contains sugar, so we shouldn't even go for the sweetness of the sugar, and then we put too much in the whatever, whether it is hot water or coffee or milk or whatever. But those are the kind of solutions that we make at home. There are other solutions, even when you make the porridge, because porridge, you have either the flour coming together with the liquid, and you're making the porridge, the water, which is the solvent, and the flour is the solute. So you are still making the solution. But this time around, we are going to see the concentration, how much. So the concentration deals with how much that is put in the liquid. If you are adding the salt into the water, sometimes we make these even solutions when we are making the oral rehydration salts. When you go to the hospital, maybe you are dehydrated, then they can even give you some of these oral rehydration salts to hydrate your body, because you have lost a lot of water. You need to be hydrated. So the solutions, the oral rehydration salts, are also kind of solutions that we meet in everyday life. So when we talk about the solutions, don't think we are just coming with something very new. It is something that we do in every day-to-day activities. So we have looked already at what we are expected to do. So when we talk about the concentration of a chemical substance, as I said earlier, This expresses the amount of substance present in the mixture. In the mixture, because when you have the water and the salt, or you have the water and the milk, that is a mixture. So how much of the sugar have you added into the cup of tea? That expresses the concentration. Just take a look at this one. So you have small quantity of the solute per unit volume. That means you have this big cup, and then you add maybe a quarter of a spoon, tablespoon of sugar. That is some very few. You have small particles. That means we are saying small quantity of the solute per unit volume. So the volume is too high compared to the sugar if you are using water. So the water, the salt that you have, rather the sugar you have put there is much smaller compared to the water in there. So that we call it a dilute solution. Concentrated, you have added now. You keep on adding 1 spoon, 2 spoons, 2, 3, and you keep on testing. What does it happen? It keeps, the sweetness increases as you add more. And this is what happens over there. So you have a large quantity of the solute in a unit volume of the solution. And this is what changes. I'm just assuming here this is colored. You look at the color changes. So this is too light, so that means it is dilute. As you add more, then it becomes more concentrated, so the color also is changing. So the color change is going with the concentration of the solute that you are adding in there. That is just another simple example. Look at this one. This one has very little solute in it. So when you add more, the solution is becoming a little bit concentrated. And as you continue, some of the solute may not dissolve. This is a super saturated solution. This is a saturated solution, and this is a dilute solution. This one can dissolve a lot of more solute because it is still dilute, and can dissolve a little more of the solute, so it can still dissolve. But the concentration is increasing. The color is, when you look at the colors over there, you see the change in the concentration and what happens as you add more the solute into the solvent. So let's go straight to the units of the concentration. Do we say spoons per 1 cup of tea as a solution? Do we say 2 spoons per 1 jug of milk? No, we don't use those ones. This is what we use. Some of them may either be common, or some of them you may not be familiar with them. So we have what we call mass percentage. And what do we mean by mass percentage? For example, I've just given you an example. You have 30 grams of sodium chloride. 30 grams of sodium chloride. Sodium chloride is the table salt, you know. And then you add 70 grams of water. So the water is also expressed in terms of mass. 70 grams of water. Assuming the density of water is 1, that water is pure, and we assume the density is 1 gram per centimeter cubed, then the mass of water will also be 70. Now, 70 grams of water would be that solution. So you make the solution. You have 30 grams of sodium chloride. Sodium chloride is the table salt. And then you are adding 70. This one, you add 70 grams of water to make the solution. Of course, when you're making the solution, you need to dissolve. then you express, this one can be expressed as mass percent in terms of the percentage. So the mass percentage will be the 30 grams. So when you say the mass percentage will be the mass of sodium chloride, which is 10 grams, divided by the total mass of the solution. What will be the total mass of the solution? So the solution is made up of 30 grams of sodium chloride and 70 grams of sodium chloride multiplied by 100. That makes the mass percentage of the solution. So the mass percentage is equal to the mass of the solute. The solute is sodium chloride divided by the mass of the solution. The solution, remember, is made up of water and the sodium chloride. Then we have parts per million. You may not be familiar with this. Parts per million. This is the same as mass percentage, but this one is used when the concentration, when the amount of the solute is too small. Is too small, especially when we are adding small quantities of the solute into the solution. We have to use parts per million. And the parts per million is the mass of the solute divided by mass of the solution times, this is a million, 10 to power 6. That is parts per million. So we can also look at what we call percentage by volume. So the percentage by volume, so in this time, the percentage is expressed, the volume expressed in terms of percentage. The first one was the mass expressed in terms of percentage. So this is percentage by volume. So the volume of the solution is expressed in terms of the percent. Just take an example of this. We mix 30 milliliters of ethanol. 30 milliliters of ethanol with 70 grams of water, 70 milliliters, not grams, milliliters of water. They are mixed together. So what will be the percentage of ethanol? The percentage of ethanol. So that ethanol is labeled as 30%. Now that means it is almost, but we have only changed the volumes. We had masses, so this one is changing into the volumes. So the the percentage by volume, so they can call it volume percentage. Volume percentage will be equaling to the volume of the ethanol, over the total volume of the whole solution. So we have the volume of the ethanol, then the total volume of the solution. So the solution is made up of, this was 30 milliliters over, you have 30 milliliters of ethanol plus 70 milliliters of water. That solution is labeled as 30% ethanol. Some of these drinks, alcoholic drinks, are labeled in terms of percentages. Most of them you'll find, some of them are 5%, are 6%, 12%, 48%. This is what it means. The amount of the alcohol expressed in terms of percentage. So even when you are taking alcohol, I hope you are not taking alcohol because you are not allowed by your age. I mean the senior threes. or any other person below the age of the 18, you are not supposed to take the alcohol, please. But when you look at, you are not denied to look at them. You can just take the bottle and look at it. And then look at the percentage of the alcohol. So you'll find the percentages are varying. So we call it percentage, or the volume of the alcohol will be expressed in terms of the percentage. So the most common that we are going to talk about to emphasize today that we use is what we call morality. However, these are not the only units that we have mentioned. There are so many other units. We have parts per billion. We have the mole fraction expressed in terms of the mixture, expressed in terms of the solution, and so many others. These are a few of the units that we have to look at. Morality. The number of moles of the solute dissolved in 1 liter of the solution. Please take a very big note of that. The number of moles of a solute, I just want to underline that, in 1 liter of the solution. That is what we call the morality. For example, the example I've given there, 90 grams of glucose. Glucose is used by athletes because they use a lot of energy, so this glucose is consumed because it can be converted easily to produce the energy, the immediate energy that is required. So 90 grams of the glucose has a molar mass of 180 grams. This corresponds to 0.5 moles. How do we get that one? How do we know that is 0.5? You know the number of moles from your senior 2. The number of moles of the solute. We said the moles of the solute dissolved in 1 liter of the solution. That is very important. So 90 grams is equivalent to 0.5 moles of the solute. Now, these moles of the solute, if you get 90 grams weighed exactly, this one is equal to 0.5 moles. And then you add this into 1 liter of the solution. This solution is labeled as will be 0.5 molar. Morality is expressed in as the capital letter M, or it is 0.5 moles per decimeter cubed. Moles per decimeter cubed. Remember, 1 decimeter cubed is equal to 1,000 cubic centimeters cubed, which is equal to 1 liter. So when we express this one, so moles per decimeter cubed, or we can say 0.5 moles per liter, that gives us the morality. The number of moles expressed, the number of moles dissolved in 1 liter of the solution. So these are the units of the morality. Morality is also a unit of concentration. Let's proceed. That is what I was just talking about. Please make sure you remember this, that 1 decimeter cubed is equal to 1,000 cubic centimeters and is equal to 1 liter. So that is a very important note that you should not forget. So we're coming to preparation of the solutions. When we are preparing the solution, we said this method of preparation, there are two methods. We have dissolution method, and then we have dilution method. These are the only two types of making solutions. When you are making a solution, there are only two types. But for today, we are only going to look at the dissolution method, or this one is called weighing method. So the weighing method means that we have to take the weight of certain components. And after weighing that, the solution that we will make at the end of using this method, if we are able to go through the steps, this solution that we will make is said to be a standard solution. What is this standard solution? The solution whose concentration is known. This is a solution whose concentration is known. A solution whose concentration is known. Is known. So when I say 0.5 moles per liter of glucose, that is the concentration, and that solution is standard. So for example, here, there are certain steps that you have to go through when you are preparing this standard solution, which we said is a solution whose concentration is known. Step number one, you'll need to weigh the mass of the substance, that is the solute. Because once you are making the solution, you need the solute and the solvent. Those two main components. So you need to weigh the mass of the solute. Two, the solute has to be dissolved in a solvent. And that solvent, in this case, we are using water. And then it will be transferred into a liter. If we are making 1 liter, and then we label it. We have to stop, you have to cover it, we have to make sure we put a stopper or recover that solution. Why are we covering this solution? Because some of these substances are hygroscopic. What do I mean hygroscopic? They absorb the water from the environment. So when they absorb the water, then their concentration can change. So that is why immediately we have to cover them. So let's do one example. This is the method, sodium hydroxide. You want to calculate, you want to make, remember we are making a solution of 0.5 molar decimeter cubed into 1 liter, 1 decimeter. Prepare 1 decimeter cubed of 0.5 of aqueous sodium hydroxide. So what do? You need to calculate the mass of sodium hydroxide. The mass of sodium hydroxide, calculate the mass of sodium required to prepare 0.5. So when we say 0.5 moles is equivalent to what? 0.5 moles. So 1 mole of sodium hydroxide, 1 mole of sodium hydroxide is equal to 40 grams. Where am I getting this? This is 40 grams per mole. This is 23 plus oxygen plus 1. That gives 40 grams per mole. Now 0.5 is a half. So because we are supposed to make a 0.5 moles in a liter. So that is a half of this. So 0.5 of this is 20 grams. So we have to measure, we have to weigh 20 grams exactly. And then after weighing that, we transfer that one No, before that, transferring, we have to dissolve it in water. After dissolving it in water, transfer it into a volumetric flask. And then fill it up to the mark. So this is, if this is the volumetric flask, this is and it has the mark here. So you have to transfer these 20 grams up to this mark. And then make sure you stop this. This solution you have made here is equivalent to 0.5 mole per decimeter cubed. And this is a standard solution. So you have to make sure that this one stops over here exactly on this. So you have to be very careful when you are adding the water to make this. So those are the steps. So that is where you have carefully transfer the solution into this volumetric flask. This is where you are adding the distilled water up to this mark to make sure that you make exactly that 0.5. So that is very, very important. So moving to the next part, we are supposed to explain how we can prepare solutions containing, that is part A. This is part of the homework that you are supposed to do, but I'm just going to guide you. For example, copper 2, 0.1 more copper 2 sulfate. So when you have copper 2 sulfate, you need to get the mass contained in 1 mole of this. Copper is 64 plus 32 plus 16 times 4, and then you get the molar mass in 1 mole. So after getting this, you look for 0.1 mole is equivalent to what? As we did here, 0.5 was equivalent to 20. So what will be the mass that you need to dissolve? After that, transfer it to volumetric flask carefully, and then fill it up to the mark. The same copper 2 sulfate, different concentration, but this time you need to make half a liter, not complete liter. So what do you do? So that is, please capture that one and then try to do that exercise and complete it. In the next session, we'll have to go through and compare the answers that you have got. I hope you have got the questions well. I thank you so much for this session, and I expect to be with you in the next session. See you there. Bye-bye.